So the question is, this is question 7, and it's asking, determine the pH of a 0.105 molar of NaF solution if the Ka for HF is 6.8 times 10 to the negative 4. So we have two givens, which is a molar of NaF and the Ka for HF, which is the acid. So NaF is, as we know from ions, going to Na plus and F minus. So we have 0.105 molars. So since we know from that each of them have 1, so it's just 0.105 molar of ions each. And that's the initial concentration. So we take this and we bring it over here to F minus, because when F minus it mixes with H2O, it makes a conjugate acid but with a really strong base. So we have a 0.105 initial molar, and since we know this is a salt equilibrium problem because of NaF, we don't use water in this situation at all, or in any equilibrium problem, because H2O is a pure liquid. And we know that there's no initial concentration given for HF and OH, so we put 0 in for that. So we put in X's, since each have a 1:1:1 mole ratio. And so it's important that you put in your signs as well. So that's to be negative, because I'm looking ahead to the future. That 0.105 minus X, and these are just going to be positive. So in here, it's going to be 0.105 minus X. You bring it all down, just positive X's. All right? And now, so you're going to plug these into this equation, Kb equals HF, OH minus, and F minus. So you have Kb equals X squared, which is HF, OH. These two just multiply together, you get X squared. So 0.105 minus X. Alright? But here's the tricky part, is that you have the Ka, which is 6.8, but you need the Kb because of this OH right here. You're finding the acid, the base rather than the acid. So what you do is you have this equation. You know that the Ka times the Kb equals 1.1 times 10 to the negative 14th. So you're just going to plug this in. So it's 6.8 times 10 to the negative 4 times the Kb, which equals 1 times 10 to the negative 14. And you should get an answer of approximately 1.470588 times 10 to the negative 11. Alright? Then you're going to take this, since this equals your Kb, you're going to plug it into here. So I'm not going to rewrite that, but since if you already know the trick, you can just cross this out because of this 10 to the negative 11 portion. So you're going to do multiply and take the square root of it, so you get X equals 1.242625 times 10 to the negative 6. The only reason why I'm having so many sig figs is that you don't round sig figs until the very end, so I'm keeping as many numbers as I can so they remain accurate. So I know X equals 1.242625 times 10 to the negative 6. So we're going to take that, bring it up to the OH, because it's the same as X. And since we need to find the pH, you have the OH. So you're going to take OH concentration, plug it into this one right here in the negative L. So when you take that answer, you plug it into a calculator, you get 5.9055. You take the pH plus 5.9055 equals 14. Subtract that over pH equals 8.1. And you know this is your answer. This is what it's asking for.